Welcome to a lesson with Dr. Powell. Let's look at a practice problem of finding the tangent line to a curve defined implicitly. Notice we have not solved for x or y here when we want to find the equation of the tangent line at a particular point when x is pi and y is pi. How are we going to do that? First we need a slope, and then we have our point. So with a point and a slope, we should be able to find the equation of the tangent line. To find the slope, dy dx, this is one way of doing so, using boxing technique for taking derivatives, which is akin to product rule. So first of all, I'm going to put everything on one side and 0 on this side. Derivatives of both sides. Derivative of this side is easy. It's just 0, right? Aha. What about the derivative of the other side? So what we're going to do is we're going to take the derivative of this side with respect to wherever we see an x. We're going to let those guys be variable. X is being variable, and everything that's not x, like the y, we pretend that those guys are constants. So it's like if you boxed all the x's, we're going to treat all those at once. And then we box all the y's, we'll treat all those at once. So it's like we take the derivative pretending that y is constant and x is a variable first, and then at the end of doing that, multiply by the derivative of the variable you have, x, well, dx, the derivative of x with respect to x is just 1. But I just did that for kicks so we can remember proper boxing rule technique. Notice it's pretty much a lot like the product rule is just an example of boxing. Then what we do is we take the derivative of this whole side with respect to y, where y is the variable, and wherever we see an x, that's a constant. So then you take the derivative of, with respect to whatever the variable was, which in this case is y, with respect to x. X is kind of what we're ultimately in the end taking the derivative with respect to. So we do that both times. We add those results together, and that's the derivative of that side. This is a beautiful way of doing so because immediately you have dy dx right here, and you can solve for it quickly. It's factored out already. You can just swiftly move to that. So let's walk through those details of how this is done. First, so this portion right here is the result of taking the derivative of this side with respect to x, pretending that y is a constant. So in doing so, you have first to take the derivative of this over that. Now notice if y is a constant, derivative of this part's just like 0, the sine y minus pi halves, so that part's gone. So it's really just this fraction. This particular time, I'm going to use the quotient rule. All right, so the derivative of the top with respect to x, y is constant, like y times x. It's like, you think of y as being like 5 or something. This is like 5x. So the derivative of 5x is 5. 5 is representing y. It's y. So the derivative of the top is y times the bottom. Okay, the derivative of the top times the bottom minus the top times the derivative of the bottom with respect to x. Remember, derivative of this with respect to x, remember y is constant. That goes away. Derivative of x is just 1, so 1. So we've taken so that's the top, and the quotient rule, the bottom is just that denominator squared. So we took the derivative with respect to x, and in the end, after we do this in the boxing technique, proper protocol is multiplied by the derivative of whatever we had boxed, which was x here. So dx dx. So plus, and then right here, what are we going to do? Take a derivative with respect to y, where y is the variable and x is a constant. So similarly, right here, quotient rule on this, and then derivative of this. Notice that derivative of negative sine y will be negative cosine y, and then derivative of a constant negative pi halves will just simply be 0. Okay, so, all right, with that being so, and then you can check the quotient rule here. The derivative of the top with respect to y is actually going to be x. Remember, if y is the variable, it's like x is like constant, so pretend like x is like 5 again, so like 5y. Now it's the derivative of 5y with respect to y. That's just 5. Well, 5 is representing x now, so that's just x. The derivative of the top is x, the bottom is just x plus y, minus the top times the derivative of the bottom with respect to y. With respect to y, x is a constant gone away. So derivative of y with respect to y is just 1. So, and then the denominator squared. Quotient rule part done. You have minus, so sine y, derivative of that, minus cosine y. Okay, this is good. And then times dy dx, derivative of y in the end. Okay, so we take this part, and this is nice. Now, dy dx, what is it going to be? It's going to be, so if this whole part is lassoed over and brought to the other side, it's going to be negative. So it's going to be like the negative of this divided by this whole part to give us dy dx. Now, plugging in pi was kind of a nice choice, kind of symmetric in a way. Whatever this is, right? Notice that this is going to be the exact same as this when we plug in pi, even if we don't keep on simplifying, which we could, but even if we didn't, it's going to be the exact same. And in fact, you could even see this is going to be a fourth and a fourth. It's 2 pi squared minus pi squared is just pi squared over 4 pi squared. That's pretty nice. It's just a fourth and a fourth. But since this is the same as this and this is just brought over, in fact, we could write that out if you want. So this is really just a fourth plus a fourth dy dx is equal to 0. Of course, this is dy dx evaluated at pi at a particular point. You bring that 1/4 over, it's negative a fourth is equal to a fourth dy dx, and then divide both sides by a fourth. You'll end up getting negative 1 for dy dx. So the slope at this particular point is negative 1. All right, now how can we use that to find the equation of the tangent line? Well, we can just use this basic idea. Slope is equal to rise over run, the change of y over the change of x. One of the points is xy, and the other point is pi, and then you think, okay, the rise is y minus pi. The run is x minus pi. So that's going to be equal to the slope. But the slope is negative 1. And just rearrange this to get rid of the domain problem. So x minus pi on this side, there's your equation of your line. Just rearrange here, multiply this negative in. Negative x plus pi, and then you can add this pi over here. You're going to get negative x plus 2 pi is the tangent line to that curve at the point pi. Thanks for watching.